DeepSeek harness is hot. What does it actually add to an AI agent? This episode gives you a screenshot-ready DeepSeek harness 5-layer mental model. You will be able to identify what sits around a model without memorizing the codebase. In August 2026, DeepSeek AI released DeepSeek Harness DSH v0.1.0 RC7. The official README calls it an open-source agent harness and says its architecture treats everything as a plugin. Keep the boundary visible. This is a developer preview, and the project explicitly warns about compatibility-breaking changes. GitHub attention is a trend signal, not evidence of quality, performance, security, reliability, or production maturity. This video is packed with practical, high-value insights to help you get better at using AI. It's a longer one, so follow Tiny Agent and save it so you don't lose it. First, separate the model from the harness so you can see why DeepSeek Harness is not merely another chat interface. A model generates the next response from an input. An AI agent also needs a way to continue work, expose actions, preserve facts, and limit what execution is allowed to do. With only a model, each request resembles an isolated answer. A tool registry, durable session facts, execution permissions, and replaceable runtime surfaces do not appear automatically. A harness is the execution shell around that model. It connects model requests, tool calls, state changes, and human control into a runnable chain. The DeepSeek harness architecture documents treat the model adapter, tool registry, session log, and agent loop as plugins rather than parts of a privileged core. That changes the first question to ask. Do not stop at which model is installed. Inspect which runtime loop, capabilities, state, and controls surround it. This episode answers only what DeepSeek Harness is and what it adds. A separate source reading map can explain implementation, while a separate adoption checklist can cover setup and fit. Chapter recap. First, a model generates output but is not a complete AI agent. Second, a harness connects requests, actions, state, and control into an executable chain. Third, understanding DeepSeek Harness starts with the execution shell outside the model. Now split that shell into 5 layers so you have a reusable way to recognize an agent harness. Layer 1 is model access. Adapters connect models to a common request surface. The model is the engine, not the whole vehicle. Layer 2 is the agent loop. It decides how a turn claims input, makes a model request, handles tool calls, and continues when more work is owed. Layer 3 is tools and capabilities. A scoped registry exposes file, terminal, search, or other actions while allowing checks around execution. Layer 4 is sessions and state. An append-only session log records user messages, model output, and tool results so recovery, replay, and interfaces can derive from the same facts. Layer 5 is control and surfaces. Sandbox policy, approval, credentials, settings, and web or headless entry points determine where the agent runs and who releases sensitive actions. These 5 names are an episode synthesis from the README, architecture documents, and base bundle. They are a mental model, not an official DeepSeek taxonomy. Chapter recap. First, model access answers which engine is connected. Second, the loop, tools, and session layers explain how work continues and leaves facts behind. Third, control and surfaces explain where execution runs and which actions can be released. Next, interpret everything as a plugin so you can understand why the 5 layers can be recomposed. The official architecture describes a running DSH instance as a plugin tree. Plugins contribute services, typed events, and reversible effects to a shared context. The important point is not the number of plugins. The model adapter, tool registry, session log, and agent loop all join through the same extension mechanism. An extension can therefore mount beside existing plugins instead of patching a privileged core. When a plugin unloads, its registrations unwind with it. A profile names an assembly, a bundle distributes configuration and mount code, and later patches can replace earlier configuration rows. The base bundle shows the practical breadth of the tree: models, sessions, tools, sandboxing, approvals, credentials, settings, and telemetry are all assembled as entries. That still answers what the system is. It does not explain every implementation detail, and it does not prove that the architecture is faster or superior. Chapter recap. First, DeepSeek Harness runs as a plugin tree. Second, several core capabilities enter through one composition mechanism. Third, replaceability does not prove benchmark leadership or production maturity. Now focus on replaceability. So, plugin architecture means more than an app marketplace. The architecture calls a replaceable capability a seam. A complete seam normally includes a service definition, a provider that implements it, and a consumer that uses it. For example, file system and process execution can point at a local environment or another provider, while model-facing tools keep the same capability boundary. Model adapters, tool execution, session storage, and interface surfaces can change along their own seams instead of forcing every variation into one giant loop. What this adds to an AI agent is not merely a longer feature list. It makes responsibility visible: who declares a capability, who provides it, who consumes it, and where policy intercepts it. Visible boundaries let people inspect models, tools, state, and permissions separately rather than assuming that a runnable black box is trustworthy. But plugin composition does not erase the developer preview boundary. Real adoption still requires validating configuration, permissions, data handling, compatibility, and failure behavior. Chapter Recap. First, plugins matter because they create explicit capability seams. Second, providers can change behind a stable responsibility boundary. Third, clearer boundaries improve inspectability but do not automatically create quality or reliability. Finally, compress the episode into a 5-layer mental model you can reuse whenever you evaluate an agent harness. Layer 1, Model Access. Inspect how models connect, adapters are selected, and requests are formed. Layer 2, Runtime Loop. Inspect how input, model steps, tool calls, and stopping conditions become a continuing turn. Layer 3, Tool Capability. Inspect which actions are exposed and whether execution can be checked, limited, and recorded. Layer 4, Session State. Inspect whether model visible history can be rebuilt from durable facts and whether recovery and replay share that source. Layer 5, Control Surfaces. Inspect how sandboxing, approval, credentials, settings, and runtime interfaces constrain the system. Add one boundary whenever you use the map. It explains composition, not quality. RC7 is still a developer preview, and attention is not performance or maturity evidence. Screenshot DeepSeek harness, model, loop, tools, sessions, control. Chapter Recap. First, begin with model access and the runtime loop. Second, inspect tool capability and session state. Third, finish with control surfaces and validate the developer preview boundaries separately. DeepSeek harness is hot. What does it actually add to an AI agent? It adds a composable execution shell around the model, organizing the loop, tools, sessions, controls, and runtime surfaces as a plugin tree. The 5-layer map identifies composition. It does not replace testing. RC7 remains a developer preview with possible compatibility breaks, and attention does not prove quality, performance, security, or production maturity. Which of these 5 layers do you most often overlook when evaluating an AI agent project? Share your reasoning in the comments. Follow Tiny Agent. Tiny Agent helps you get better at using AI.